the zero product rule. What is the zero product rule? Well, if you have an equation that says a times b equals 0, this is true if a equals 0, because if a equals 0, that means that we can write 0 times b equals 0, and according to algebraic rules, anytime you multiply 0 times any whole number or any number, you get 0. So also, if b equals 0, this implies also that a times 0 is equal to 0, because 0 times any number will be 0. So if we apply it to an expression such as x minus 3 equals 0, for example, then we can apply this rule by assuming the following. Since we have a product of two things, the left side could be the a part and the b side could be the right side. So we say if a equals 0, that means we have to say that x must be equal to 0. That gives us one of the solutions, so x equals 0 is one solution. And if b equals 0, then this implies that this whole expression here, x minus 3, must be equal to 0. And for that, we have to determine for what values of x will this little equation here be 0. So in this case, if we solve for x, we can clearly see that x will have to be equal to 3. Now, let's take another example. Something similar, but let's expand it to two binomials like x minus 9 and x plus 6 equals 0. Again, we break it up into two parts, a little chart like this. This is our a, this is our b, and of course if a equals 0, then 0 times b will be 0. So we assume that this right here will be our a, or that x minus 9 will be equal to 0. Again, if b equals 0, then 0 times a will be 0. Then we can assume that this expression here, this expression here, x plus 6 will be 0. Now, what makes this little expression 0? Well, obviously this will be x equals 9, and this will be x equals negative 6. And we can actually expand this as many times as we need to. For example, suppose we have something like x minus 1, x plus 3, 2x minus 3, x minus a third, and so on. It doesn't have to be a times b, it could be a times b times c times d equals 0, and then each of them will have to be equal to 0. So in this case here, we can see that whatever makes this 0 will be 0 times any number will still be 0. So we say that x will have to be 1, x equals 1. Here, x has to be the opposite of that, will be negative 3. And then this one we have to solve for x. 2x minus 3 equals 0, or 2x equals 3, x equals 3 over 2. And finally this one, x minus 1/3 equals 0, or x is 1/3. If I were to substitute that in here, I get a 0. 0 times anything will be 0. If I take this term here, negative 3, and plug it in here, negative 3 plus 3 is 0. Then that means that I can multiply 0 times any number, and I still get a 0, and so on. Alright. Now, if I have expressions that look like 2x minus 5 times 3x minus 1 equals 0, there is no difference. We can still use our zero product rule. So again, this will be 2x minus 5 equals 0, or 3x minus 1 equals 0, which gives us 2x is 5, or x equals 5 over 2. This one, of course, is pretty straightforward. 3x equals 3x minus 1 equals 0 gives us 3x equals 1, or x is equal to 1 over 3. And again, you can apply this to many factors, provided that they're all products. I hope that helps.